Hi everyone, welcome to the data extraction training for our buprenorphine and quality of life meta-analysis project. The first thing I want to do is provide a brief introduction into effect sizes and go over some basics of how we are going to extract data into a spreadsheet. So first off, what is an effect size? It's a statistical concept that measures the strength of a relationship between two variables on a numeric scale. In meta-analysis, effect sizes are the unit of analysis. We will mostly be using pre-post effect sizes. You can see on the right, we've got the formulas that we'll be using. Our Excel spreadsheet will have a formula in place to calculate these for us, but we need to pull out the values that the formula will use. So you can see on the right, we've got the effect size is equal to Y post, which is the quantitative quality of life value at the post assessment, minus Y pre, which is the quality of life quantitative value at the pre or the baseline assessment, divided by S within, which is taking the standard deviation for the pre-value squared plus the standard deviation for the post-value squared divided by 2, and then taking the square root of all of that. So what do effect sizes tell us? First off, I want to point out all the way on the right over here, these are all the effect sizes for these different domains reported in all of these studies. And then you can see at the bottom here, we've got the random effects model average effect size. So this is across all studies, we have an average effect size. So first off, effect sizes tell us if there is a negative, null, or positive effect of an intervention. So if this effect size is greater than 0, we can see that there's a positive effect. In our case, it means a positive effect of buprenorphine on quality of life. So on the right here, this is an example from my final project in my meta-analysis class, but the average effect size is 2.8, which is pretty large. So it shows a large effect of buprenorphine on quality of life. The second thing that effect sizes can tell us is how the effect varies depending on certain other factors. We're going to use this statistical technique called meta-regression, but you can start to get an idea with the forest plot on the right about how things might vary, how effect sizes might vary depending on certain factors. The first thing you see is that these effect sizes are clumped at the study level, or at individual samples tend to have similar effect sizes across the 4 different domains. Another thing you can see is that in this Kapoor study, they report 2 separate groups. So Kapoor 1 is heroin users, and Kapoor 2 is prescription opioid users. So the effect of buprenorphine on quality of life is larger for heroin users. We're going to have a lot more effect sizes, so we'll be able to do this with a lot of different variables, and it'll be really interesting. But this is just a small example based on 4 studies. So I wanted to give you an intro into what effect sizes are so you understand why we're pulling these numbers. I feel like that helps me a lot. So a single study can have multiple effect sizes, and each effect size is going to get its own row, and that's labeled ESID, or effect size ID, in the spreadsheet. So what makes a unique effect size? Different effect sizes will be recorded for different quality of life instruments. So for example, if a study reported the WHO quality of life instrument as well as values for the SF12, those would get different effect sizes. Or if they report different follow-up times. So in our example here, you can see they reported quality of life values at 3 months, 6 months, and 9 months. So all of these are going to get different rows in our spreadsheet. Same thing for different domains, physical, social, psychological, and environmental. They all get their own row. And group. It's not the case in this study here, but in that Kapoor study, they all got different rows or different effect sizes depending on if they were a prescription opioid user sample or heroin user sample. So another example is in this table, we've got 16 unique effect sizes. Each red box is going to get its own unique effect size or unique row in the spreadsheet. These unique effect sizes are based on the differences in follow-up time, the 3 months versus 6 months, differences in group. They've got 2 samples reported here. One of them received outpatient services in addition to buprenorphine, and the other group received intensive outpatient services in addition to buprenorphine. And then we've also got 4 different quality of life domains reported, which are all going to get their own effect sizes. This is how I would extract all of this data into the spreadsheet. It doesn't really matter what order you do it in. So I first grouped by domain, but you could group by follow-up time first. It doesn't really matter. We're going to end up with the same rows. They just might be in a different order. The next thing we have to do is extract the other data, so not the quantitative data, but the other things that we've coded for in deduce. For example, we've coded for sample characteristics, like the percentage of the sample that's male, or the average age of the sample. We've also coded for intervention characteristics, like the average buprenorphine dose, or adjunctive services, like if individual counseling was provided. So you will fill in the other info for each effect size or each row. Within studies, a lot of this information is going to be the same, but not everything. An example of when things are not necessarily the same in the same study, we'll go back to the Kapoor study. So the heroin users and the prescription opioid users, they all get their own rows, as you can see here in the group column. You'll notice that when you get over to the heroin column, and that variable is the percentage of the sample that are heroin users, you'll see that in rows that are for the heroin user group, this heroin value is going to be 1. In the prescription opioid user rows, that value is going to be 0. So the reason I'm pointing this out is just to say to be careful when you're filling these in and don't just assume that they're all the same. Try to think critically as you're going through if there's any reason that they would differ depending on the different effect sizes or rows for a study. So finally, I've got a couple overall tips. So first, I would start off with effect sizes or the quantitative values. That's the first thing I'm always going to do when I start extracting data into the spreadsheet. In Deduce, you can use the measures of effect code or go to the article itself to do that. Once I've got all of the rows started and I know how many rows there's going to be, I'm going to fill in the quantitative data, and then I'm going to fill in the rest or the other data. And I'll use Deduce's excerpts tab for that. It's also really important that you reference the data extraction instructions Word doc, and also watch the example video that I provided. I think that will clarify a whole lot about how you should go about data extraction. If you have any questions, please let me know.